Hey folks, so hopefully you're watching this live, and let's get into it. We're going to be talking about something called sigma notation, and sigma notation has to do with something we call a series. So some vocab first. A series is the indicated sum of a sequence, so we're just adding a bunch of stuff together. In other words, I tell you, hey, add these things up from a sequence, add the first 20 terms, and you do it. Sigma notation is always going to refer to addition. At no point are you going to subtract, multiply, divide, exponents, anything. Now, you might do them while adding, but you're never going to say, like, I found this term and subtracted it from the next. You're always going to be adding them. Other operations in math do repeated subtraction, multiplication, or division, but not sigma. So what is sigma? Sigma is a Greek letter. It looks like an uppercase E, but it's actually more closely related to an uppercase S. It's actually where we get our S. You've seen a lowercase sigma before in Algebra 1 for standard deviation. It's a little symbol that looks like this. So, the following is from varsitytutors.com. I'm clearly stating where I'm getting this. I did not make it. This is it. This Greek letter is an uppercase sigma. So that's what we're actually doing here. Now, if we're talking about, let's start at the bottom, work our way up. The index of summation is just this letter here. This letter will always be the same as is in your expression. The first value of n has to be given here. And it's just the first one you're going to plug in for n. And you're just going to keep plugging in until you get to the last value of n, which is given at the top. You're also always given a formula. You will never not be given a formula for the terms. So you would solve this one by doing 4 times 1 plus 4 times 2 plus 4 times 3 plus 4 times 4 plus 4 times 5 plus 4 times 6, and you would stop because they told you, hey, 6 is the last one that you're going to plug in. Let's take a look at some examples. We're going to find the value of this. There's no real nice way to say these things out loud. I'll never ask you to do so. We're going to do this by replacing n, with the bottom number, and then increasing by 1 until we plug in the last number, which is on top. You're always going to be increasing by 1 here. You're never going to skip jump, nothing like that. So that's going to give you this. The 2 is coming from my equation, my formula, my expression here, from each one. That's where that 2 is coming from. The 1, 2, 3, 4, and 5 are coming from here. They told us to start at 1 and to stop at 5. That's why we didn't start at 15 and end at 26 or something like that. Well, once you do that, you just sum it up. Well, that's 2 plus 4 plus 6 plus 8 plus 10, and the sum is 30. For my purposes, I know that you know how to add stuff up. If you were to just plug this first line into a calculator, I'll accept it. You're in Algebra 2. I don't need to see addition. Definitely feel free to plug into a calculator here. All right? I'm not testing your ability to add stuff up. I'm testing your ability to use sigma notation, which is considerably more annoying than just adding stuff up. Let's take a look at a second one. So I know I said you'd never be subtracting or raising something to a power, but notice what we're doing with these terms. Step 1 is we're going to replace the variable with the bottom number being here, the 2. Notice we don't have to always start at 1 or 0 or anything. We can start wherever. We're going to add 1 to the bottom number each time, substituting in again. Then we're going to keep going until we plug in the last number, which is on the top. Here, that's going to be 5. So we're going to do this 4 times. 1 for 2, 1 for 3, 1 for 4, and the last one for 5. Last but not least, we're going to add them all together. And especially with something like this, where this is not the easiest to look at in the world, like this might be annoying, a table really helps out. So you'll notice that first you got 2, it's plugged into here, and you get 3. Next, you plug 3 in. Well, 3 squared minus 1 is just 8. Next, we plug 4 in. Well, 4 squared minus 1 is just 15. Last but not least, we plug 5 in. 5 squared minus 1 is 24. well, I said last but not least, but this is really last but not least, you add everything together. So our answer here would be 50, right here. 50 would be the sum of this. Now, it also helps us sometimes to be able to write these things in sigma notation. So given this series right here, we want to write it in sigma notation. And we're going to do that by using some prior knowledge. First, we're going to make the equation that we used before. We have a1 equals 5 right here. We know the common difference is 8 because this goes up by 8, 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 and up by 8. Last, we know that we need 1, 2, 3, 4, 5, 6, 7 terms. So let's plug it all in. We're starting with the first term, ending with the seventh. Again, that's because we have 7 terms in this sequence up here. And then we're just going to plug in our equation. Our first term is 5. That's what happened here. The common difference is 8. If you're wondering where the n minus 1 came from, that's just from our formula for an arithmetic sequence. And this is considered your final answer. You don't have to do anything past this. This works. So, that's not to say it's the only thing that works. Both of the sigmas over here, this green one and this blue one, will give the exact same sequence that the one we made did. Delta Math is going to tell you something like these two. I checked, you can totally plug in one like on the previous page. Don't worry about that. So, a summary. That's it. That's the lesson. It's a short one. So, you only have one Delta Math problem set here. It's very similar to example 3. Then you're going to read section 6.5, geometric series. We're skipping 6.4, so don't worry about that. And we're doing the reading check. All right, so you're doing 6.5. If you are looking at the reading summary and you're like, I have no idea what's going on, you may have read the wrong section. Go back and read the right one. Last but not least, you have a writing assignment. It's posted in a separate assignment. Just like the last Flipgrid, you have an option on which ones you're going to do. I figured why not? I'll just try to give you an option when I can. You're just doing one. There is no extra credit for doing extra. Stay safe. Talk to you soon, folks. Have a great weekend.